Today's topic will be on solving mixture applications with a focus on coins. So let's look at it this way. We will have two or more items with different values to combine. The mixture model is used by individuals to make sure that they set fair prices for the products they sell. That's just a small example. Another example is that many other individuals or professionals like chemists, investment bankers, and landscapers also use this mixture model. So let's take a look at the total value of coins. So for the same type of coin, the total value of a number of coins is found by using the model number times value equals the total value, where the number is the number of coins in general, the value is the value of each coin, so think, a quarter is 25 cents, a dime is 10 cents, so on and so forth. And the total value is the total value of all the coins when added together. So, for example, all the coins will equal $2.25 in total. So, let's look at this. The number of dimes times the value of each dime equals the total value of dimes. So the number times the value is the total value, where 17 times 10 cents is $1.70. And we can use this chart to take a look at that value. And we will be using this chart throughout the duration of the video. So if you notice, I'm going to get my laser pointer here. We have the type in this column here. Then we have the number in this column. And then we have the value in this column. And then we have the total value in this column with the subtotal in this box right here. So, let's take a look at an example. Jimmy has $2.25 in dimes and nickels in his pocket. He has 9 more nickels than dimes. How many of each type of coin does he have? So, let's read the problem and make sure it's clear what we're looking for. And let's create this table. So, in the third column, you can see the value. We know the value of a dime is 10 cents and the value of a nickel is 5 cents. And the total value when put all together is $2.25. So let's identify what we're looking for. We are asked to find the value of dimes and nickels Jimmy has. So we are going to name what we are looking for by letting D equal the number of dimes and D plus 9 equal the number of nickels, noting that these are two separate variables. The D is simply just the number of dimes, and because there are 9 more nickels than dimes, we're going to set up another one that is just D plus 9, which will equal in the end the number of nickels. So when we put this in a chart, we have the second column as the D in dimes and nickels, which is D plus 9. So now we apply the number times value equals total value rule, where we get in the last column 0.10D, and in the second column, and in the second row, we have 0.05 times D plus 9, and in total, that's going to equal 2.25 in the end, $2.25. So we're going to translate this into an equation where we have the value of the dimes plus the value of the nickels, which will just simply equal the total value of the coins. Let's just go back to simple algebra on that one. And then we have the values for each one of those underneath the brackets. And we are going to solve this equation. So 0.10D plus 0.05 times D plus 9 is equal to 2.25. We're going to simplify that to get D equals 12. And then to get the number of nickels, we're just going to simply add 9 to that. So D plus 9, which will just be 12 plus 9, is 21. We're going to check the answer by substituting into the equation. We get 12 times 0.10 equals 1.2. And we have 21 times 0.05 is equal to 1.05. And when you add those two together, you get $2.25. And we are going to finally answer the equation. Jimmy has 12 dimes and 21 nickels. Let's take a look at another example. Maria has $2.43 in quarters and pennies in her wallet. She has twice as many pennies as quarters. How many coins of each type does she have? So we're going to read the problem and make sure it's clear what we're looking for, and then create a table. So we know that quarters is equal to 25 cents and pennies is just simply 1 cent. And we have the total values is equal to $2.43 in total. Let's identify what we're looking for by looking for the number of quarters and pennies. We're going to name what we're looking for by letting Q equal the number of quarters and 2Q equal the number of pennies, because remember, she has twice as many pennies as quarters. So then we put that into our chart in the second column, and then we apply the number times value rule to equal the total value. And in the in the final column, the fourth column, we have 0.25Q in the first row and 0.01 times 2Q in the second row. And that'll in turn equal $2.43 in total. We're going to translate this into an equation and solve the equation. So 0.25Q plus 0.01 times 2Q is 2.43. So then we do a little simplification, and we get the total number of quarters is 9. And then we have to find the total number of pennies, which is twice as many quarters. So we do 2 times Q, which is just simply 2 times 9, and we get 18. So we have 18 pennies. And we check the answer by making sure that 9 quarters is equal to the 225. And then we make sure that the 18 pennies is equal to the 18 cents. And then by adding them together, we get $2.43. So we are correct. Then let's answer this question by stating that Maria has 9 quarters and 18 pennies.